Peter flies a kite on a 17-meter string at an inclination of 63 degrees. Alright, so let's have a look at the information that we have. So we know that the string from Peter to the kite is 17 meters. And we know that the inclination, which is the angle between the ground and the kite, is 63 degrees. So what are we looking for? We're looking for the height of the kite above the ground. So the height of the kite would then be this line over here. Let's call that y. So if we then join this line down the bottom here, we can then see our familiar right-angled triangle, which we can then use our trig functions to solve. So that is, of course, a right-angled triangle. So let's write down our mnemonic so that we have a reference and so that we can remember our trig functions. That's SOHCAHTOA. Okay, so let's identify our side. So we know that we have the hypotenuse, which is 17, and we know that we need to get the opposite side, which is y, the height. So that means that we are looking at our sine function. So if we say the sine of 63 degrees is equal to the opposite side, which is y, over the hypotenuse, which is 17, we can then algebraically simplify this so that we have y alone on one side. So we multiply by 17 on both sides. And that then leaves us with y equals 17 multiplied by the sine of 63. So let's do that on the calculator. So 63, the sine of 63 multiplied by 17. And that gives us a length for y of 15, let's round off to 2 decimals, 15,15 meters. Alright, so we know this is 15,15. Then the next question. If Peter's friend Mary stands directly below the kite, calculate the distance between the two friends. So, of course, now we're looking at this side down the bottom. Let's call that x. Let's get a different color so that we can distinguish between the two. Okay, so now we know that we have the hypotenuse and we know that this is the adjacent side. We could, of course, use the theory of Pythagoras to solve this as well, but let's do this using our trig functions. So in this case, we know that the adjacent side and the hypotenuse leads us to our cosine function. So if we then say the cosine of 63 degrees is then equal to the adjacent side, which is x, over our hypotenuse, which is 17. So then once again, we'll algebraically simplify this by multiplying by 17 on both sides. We then get x alone on one side, and that 17 multiplied by the cosine of 63 will give us the length of x. So let's do that. Cosine of 63 multiplied by 17. And that says that x is equal to a length of 7,72. Alright, and just to make sure that we haven't done something drastically wrong during this whole process, you can always just check by making sure that your hypotenuse is the longest side of the triangle. It will always be the longest side in comparison to the adjacent and the opposite sides.